Sir,
Yes, hello.
can you scroll up a bit because yesterday my internet was not. It was a bit. I'll just take a screenshot of the.
Yeah, you can take.
So is there anything like above it or?
There is phases of moon that we did.
Yeah, yeah, I did that. Yeah. Okay.
Okay. All
Yeah.
right. So now today we're going to write about the formation of these. So let's have a look. So we have now done with nebulae. So we're going to start with the creation of the sun, right? So you guys should understand that as the sun grew in size, it became hotter. Inner planets forming near sun inner planets forming near sun had a very high temperature near them. All right. Now, therefore, the inner planets are made up of materials with high melting points, all right, such as iron. All right, kids. Then now you guys need to know that only 1% of original nebula is composed of heavy elements. So inner planets could not grow much and stayed as a small size, solid and rocky, because everything, the other things which could were evaporated. Anyway, then kids, due to this temperature, molecules of hydrogen helium, water, and methane could not exist in solid state. Now, if you go away from like sun, like planets which are away, you're looking at that, you should understand that the cooler regions were further away from sun, and temperature was low enough for the lighter molecules to exist in solid state. This is the reason that the outer planets therefore could grow to a large size and includes the lightest elements like hydrogen. This is why these planets are gaseous and cold, like Jupiter, Neptune, etc. All right, kids, so you can write this down, please. And if you have any questions here, let me know.
Sir,
Yes?
sorry, can you summarize the whole thing like properly? Like,
Yeah, 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 yeah. You've written this? First, you write it down. I'll
okay,
then explain this.
sorry, can you scroll up a bit?
Sorry?
Can you scroll up a bit? Like I need to. So, yeah, yeah, yeah,
Here?
yeah,
Fine.
yeah, yeah, yeah.
Good, good. Okay. All right. Now, so done, kids. Should I explain this, please? One second, please. All right, kids. So let me just explain this to you now. So first of all, let's have a look. So you see in this picture, you might see the formation of sun is beginning, right? So as the sun is getting hotter, so it's radiating energy. Oh my God. As the sun is getting hotter, obviously it's radiating energy to all sides. So you see this yellow belt are the planets which were formed in intense heat. Now these planets have high temperature, which means if these planets were like this, they had gas and other stuff around them as well. So because of the high temperature, this gas or the particles which melted and they evaporated, leaving them as rock solid. And this is why those particles only remain which could withstand the high temperature, like iron and other heavy elements. Do you understand, Halar?
Yes.
This is why they're less massive, because rest of the mass is just evaporated. Understood?
Yes.
Now, if you talk about the planets which are further away, these planets have their gaseous, as you know. Why are these planets gaseous, like Neptune, Uranus, and Jupiter, etc.? Because they're far away from the sun, and they do not have enough temperature uh, to make those elements like hydrogen, other gases, some liquids and stuff to evaporate. All right. So even hydrogen is in solid state there. Do you get it? So
Yes.
basically, those because they must have the heavy elements, but they also have gases, which means that they grew in size because none of it evaporated. Understood? Compared to a rocky planet. Is that clear? So the
Yes.
element, the planets which are near sun, because their lighter nuclei are gone from it because of high temperature, they are smaller in size and they are mostly they contain heavy elements. The planets which are further away have gases and other elements which are lighter as well, which could not be evaporated. They're very cold, and obviously they have a higher percentage of mass as well because uh, nothing is evaporated. Understood? Like that. Very good. So this is basically the whole accretion model, that how planets were formed after formation of the sun in the center. So now let's have a look. Now, small question, just a random one, before we head on further. It states that the distance of sun from Earth is 1.5 into 10 raised to power 8 kilometers. All right. Calculate the time in minutes for the light to reach on Earth from the sun. Remember that the speed of light is given as 3.0 times 10 raised to 8 meters per second, that you guys need to remember. Okay. So given. Okay. Can you guys try this, please? Get me an answer. Okay.
Sir, done.
Done. Okay, very nice. Very nice. Very nice. Very nice. Okay. So keeping that in mind then, let's go to the next. What is the answer then?
Sir, I got 3,000 minutes.
3,000 minutes? Okay. Well, that's a lot.
Sir, I got two.
Same. 2,002. Okay. So first of all, you guys, you need to convert the distance into meters, by the way, because speed is in meters. So that will be 10 raised to 11 meters, right? Then basically the speed, like I told you, is 3.0 times 10 raised to 8 meters per second. And what you need time is distance over speed. So 1.5 times 10 raised to 11 meters divided by 3 into 10 raised to 8 meters per second. This should get you around 500. Oh, is it? Wait, isn't it 500 seconds? Let me check, huh? How are you getting 3,000?
Sir, isn't it 8 minutes and 23 seconds?
Yes, that is correct. So it is 500 seconds. And 500 seconds to convert into minutes. So you got to basically divide it by 60. Would be 500 divided by 60. So it should be 8.3 minutes. All right, kids? Please check. Let me know. All right. Now, there are certain questions that we need to answer for these, planets and why they're like that. Okay. So, I don't know, we have enough space, I think. First of all, we'll be creating a table. So, in a question, it says a table of data of planets in our solar system is provided. Now, I wanted to copy this table, but that's not fair. Wait a second. Wait a second. What to do about this table? Okay, I have an idea. You can copy this. I'll. Just a second, please. Hmm. Okay. Okay. That's pretty good. I got a workaround for that table. I'm just putting it in now. Just a second, please. Um, because then we don't have to draw this table now. That's the issue. Share. I can't. Okay. No, no, please don't do that. Please don't do that. It's bad. Okay. Another workaround. Okay. I got it on Skype. Wait a second, please. Here it is. So we have this table, which we want to put it on super bad though. Chalo, never mind. Okay. Hmm. Okay, copy. All right. So you don't need to draw this table, please. We just need to answer some of the questions from it. So in this table, you see the planet that we're going to look at, its orbital distance in million years. We're also going to look at the orbital duration in Earth years. Earth years means that compared to Earth, how fast they're going to take to rotate around the sun. Density, surface temperature, and yeah, gravitational field strength. Okay, so now let's have a look at it. The first question that we need to answer on this is that why does Mercury has a greater speed than Neptune? All right, so I'm going to write some of the questions. Then in the next part, we're going to say the gravitational field strength of Earth is about the same as Uranus. Suggest the reason why, although Uranus is 4 times larger in size than Earth. All right. Then in another question, we're gonna say part C, surface temperature of Venus is higher than Mars. Although the temperature decreases as we go towards planets further away. Suggest why. Okay, so let's answer these one by one. Now, looking at this table, it says, why does Mercury has a greater speed than Neptune? Can somebody please tell me that? Just by looking at this, please. Orbital distance means the distance it needs to cover to go around. Yes, kids. What do you guys think? Mercury is the closest planet to Sun. Okay, and so
So is Mercury lighter? That's why it moves faster.
Mercury is lighter? No, that's not true. It has nothing to do with that. It's basically what she is saying, that if you're further away from, Sun, then you have very less gravitational pull compared to others. Do you understand? So the answer for this is that as Neptune is farther away from um, sun, it also has less gravitational pull of sun, hence its speed is less. Is it clear? So you guys need to, yeah, exactly. That's correct, Abdullah. Very nice. Then, if you check the next one, it says the gravitational field strength of Earth is about the same as Uranus. Suggests a reason why, although Uranus is 4 times larger than Sun. So, if you check out, the gravitational field strength of Earth is 9.8. The gravitational field strength of Uranus is 8.7 almost. Why would they have almost the same when the size of those are quite, the size of Uranus is very big. Yes, please. What do you say? The answer lies somewhere in this, these numbers. Yes. Think. No idea, kids?
So its density is less than the Earth's density.
Yes. So density itself, you guys should understand density is mass over volume. So if it's less dense, although its volume is very big, which means the mass has to be smaller than Earth. Do you guys understand that? Maybe. Which means that the it depends on mass. That's why it's almost similar mass. So what you're going to write is that the gravitational field strength, the gravitational field strength does not depend on size, all right, but the mass. So Uranus has a smaller density. This shows that it would have smaller mass. And like Abdullah is saying, it's made from gas, obviously. That's true. That's why it will have less density. Then in the next one, it says surface temperature of Venus is higher than Mars, although the temperature decreases as we go towards the planets further away. Suggest why. Surface temperature of Venus is higher than Mars. Why? Okay, think about it. So if you see, Venus surface temperature is 462, and eh, what? I had to write surface temperature Venus higher than Mars. No, it should be, sorry, my bad. Make a correction. It should be written as surface temperature is higher than um, Mercury. It's on Mars, it's Mercury, okay? Just correct it. So as we go towards the planets, so what we're saying is that here, if you see the surface temperature of Mercury, which is closer to Sun, is less than the surface temperature of Venus. Now, the reason for this is, obviously you guys need to learn this, that Venus has a dense atmosphere of carbon dioxide. All right, this is a fact you guys need to learn. So it causes heat trapping, and this is basically called the greenhouse effect, and that is the reason this is happening. Do you guys understand that? Okay, write it down, please. I'm gonna come back in 2 minutes. Just give me 2 minutes while you write. Wait. All right, I'm back. So I hope you guys understand this. And now let's talk about the gravitational field strength. Okay. So gravitational field strength is defined as the force of attraction, which is the weight per unit mass. The symbol of that is G, and the SI units would be Newton per kg or meters per second square. The gravitational field strength on Earth, we take it as 9.8 newtons per kilogram, and on Moon, we take it as 1.67 newtons per kilogram. Now, generally seen through what you see here as well, that the greater the mass is going to be, the greater the gravitational field strength will be. So, you can write greater the mass of planet, greater the gravitational field strength of the planet. Now, this whole thing basically is given by a law that Newton gave us. And okay, quickly write this. I need to go to the next page then. Okay, so kids, now, so about this, I just want to tell you that this force that attracts other masses, the force of gravity, is given by the Newton himself. So it's called Newton's law of gravitation, right? So this is the law. In this law, he states that the force of attraction, the force of attraction is proportional to the product of mass and inversely proportional to the square of distance from their centers. Now, this is a confusing one, but I'll tell you what it means. It means that if you have two masses, let's suppose a mass m and then another mass m, and the distance between these two are basically r. So what they're saying is that this force of gravity depends on the product of the mass and also depends on the square of distance between them. This in physics is called inverse square law as well, which means is that, let's suppose, obviously the mass is not going to change of the two bodies, but if, let's suppose, there's an object that is at the surface, like maybe a person, right, at the surface of planet, so his distance from the planet is the radius of the planet itself, right? So he will basically feel some force towards it like we do. But if this person now goes to um, twice the distance away, so let's suppose this person is right now here, and his distance from the center of Earth is now 2 times r. So then, according to Newton's law, his force will be 1/4. Now, why 1/4? Because it's a function of square. Now, function square basically means that twice distance means a quarter of force. They're inversely proportional because there's a square on top. which also means if the same person then goes to a distance which is 3 times away from the center of Earth, then his force, the force acting on him, will be 1 by 9. So square, inverse square of every number that he goes forward to. Like for 2, it will be 4, for 3, it will be 9. If I ask you what will be the force, um, if he goes 4 times the distance, what would you say?
1/16.
1 of 116. Very good. So that would be the amount or the ratio of force that's going to decrease. Oh no, that's very bad. I did not write that down. Wait, it's gonna close. Chalo, koi nahi. All right. So I hope you guys understand this. And okay, so the last thing we're gonna write, and then we're gonna just meet again on Sunday to finish this up. So with respect to this, I just want to tell you that please write here, as we go away from a body like sun or earth, its gravitational field strength decreases. So with respect to sun, its oh its gravitational field strength becomes lesser and lesser as we move away from it. This is why we also say the planets which are further away from sun have lesser orbital speed. Understood, kids? Like that.
So is this like the theory of relativity?
No,
Like
that's
the gravitational field strength decreases.
gravity. No, it's not like that. The theory of relativity is about how mass and energy are related to each other. All right, and other things, including that. This is Newton's law. Okay. All right, write this down, please. So this is all for today then. So on Sunday then, let's